Alright guys, so now we are going to talk about the section 2.4, absolute value equation. First of all, pay attention to the definition. The definition is saying that the absolute value of the algebraic expression equal a number. So your algebraic expression will be equal to, well actually I'm going to do it on the side. I'm going to move my video right here, my document, and I'm supposed to have the algebraic expression equal A or the algebraic expression equal minus a, negative a. You will pay attention to the fact that your algebraic expression is standing by itself. Right here, you have no coefficient in front of your absolute value, and you don't have your absolute value plus something equal another number. It's just the algebraic expression, absolute value of your algebraic expression equal a. So let's try to do the example number 1. Based on the definition, you are supposed to be able to write now that because you have your algebraic expression standing by itself, the absolute value is standing by itself, so you can write that x plus 4 equal 8 or x plus 4 equal negative 8. You can subtract negative 4 both sides. And now, when you subtract negative 4 both sides, you can run the two calculations in the same time. You are going to have x, the 4 cancel out, equal 4, or x equal negative 12. If I do the same thing for the example number 2, we are exactly what I was telling you. Right here, you can see that your algebraic expression is not standing by itself because you have negative 2. So the first job you need to do is get rid of your negative 2. And how to get rid of a negative 2? By adding 2 both sides of your equation. So if I decide to add 2 both sides, I end up to have an algebraic expression standing by itself now, okay, equal 15. Now my algebraic expression is standing by itself. And so now I can apply my definition, and now I can write 3x minus 9 equal plus 15, or 3x minus 9 equal negative 15. Now I can add 9 both sides. I can add 9 both sides because I tried to isolate x, and so when I do so, I'm having a 3x equal 24, and right here I'm getting 3x equal negative 6. I divide by 3. I divide by 3 both sides of my equation each time, and I end up to have a x equal 8 and a x equal negative 2. Let's try to look at the example number 3. The example number 3 is very simple because what do you have is basically x plus 5 equals 0. So x equal negative 5. Okay? There is no reason for you to write x plus 5 equals 0 and x plus 5 equal negative 0. It is negative 0, it's 0. Let's try to look at the example number 4. That is a true statement. What do we have right here? We're having an absolute value of an algebraic expression equal to a negative number. And that is impossible. An absolute value of an algebraic expression cannot, let me erase this one, cannot be equal to a negative number. Because an absolute value is always positive, right? So because an absolute is always positive, that means there is no solution. Okay? That means there is no solution. Now, let's take a look at the example number 5. On this example number 5, you have the absolute value of 3x plus 7 equal the absolute value of x minus 8. The definition is telling you that when you have the absolute value of an algebraic expression equal to the absolute value of another algebraic expression, you're supposed to have x equal negative y, or actually x equal y, and x equal negative y. Well, in that case, you are going to have 3x plus 7 equal x minus 8, and 3x plus 7 equal negative, and you have to use your parentheses this time, negative 8, minus 8. And now you need to solve this by subtracting x both sides, subtracting 7 both sides, and for the other one, you are going to have a 3x plus 7 equal negative x plus 8. So I need to add x both sides, and I need to subtract 7 both sides. By doing so, what is happening? Well, pretty simple. The 7 disappear, the x disappear, the 7 disappear, and x disappear. I'm getting a 2x equal a negative 15, so x equal 15, negative 15 over 2, and on this one I end up to have a 4x equal 1, so x equal 1 divided by 4. When I look at the example number 7, I can see clearly that my algebraic expression, my absolute value of my algebraic expression is not standing by itself. It is an absolute value of x minus 3 plus 4. So the first thing I need to do is get rid of the 4 by subtracting by 4 both sides. And when I subtract by 4 both sides, I end up to have absolute value of x minus 3. I end up to have, alright, so I'm going to subtract by negative 4 both sides, and I'm going to have an absolute value of x minus 3 greater than 16. Now I can apply my definition, and then my definition is telling me that I'm supposed to have greater than 16 or x minus 3 less than negative 16. So I need to add 3 both sides of my inequality to have x standing by itself, and when I do so, I end up to have a x greater than 19 or 19 or x less than negative 13. And so my interval notation is going to be very simple. I mark my 0, so now I know that negative 13 is right here and 19 is right there. And I know that x is greater than 19, because it's greater than 19. From 19 I'm going toward to the right. Greater, there is no equal, I will use a parenthesis. X is less than negative 13, I'm going to the left. And there is no equal, so I'm using a parenthesis. So far, what I can say is that my interval notation is going to be negative infinity, negative 13, with parentheses with next to negative 13, always a parenthesis next to infinity, union, and then 19 plus infinity. Always a parenthesis next to plus infinity, and there is a parenthesis next to 19 because there is no equal in my symbol. I'll let you do the example number 8, as well as the example number 1, number 2, number 3, number 4, number 5, and number 6. Please don't forget to write the definition about the absolute value inequality in case number 1, case number 2, case number 3, and case number 4. And let's try to do that let's try to do the example number 7 by hand again. And if you want to use your calculator, you may want to use also your calculator. For that, you are going to say that because absolute value is standing by itself, we can right away write x minus 6. We can right away write x minus 6 has to be in between 2 and minus 2. Obviously, I need to add 6 both sides. And when I add 6 both sides, Okay, what do I have at the end of the day? I got a 4, I don't flip my symbol, and I got an 8. So my interval notation is going to be 4, 8, all the value in between in our solution. There is no equal, so I'm using my parentheses, and my interval notation is going to be 4, 8, parentheses. I'll let you do the example number 8. Be careful, your the absolute value of your algebraic expression 5x plus 1 is not standing by itself. Now guys, let me talk to you about the example number 1. I will let you do the other example by yourself. When you look at the example number 1, you have a true statement. An absolute value is always greater than a negative number. So obviously, because an absolute value, the absolute value of an algebraic expression is always greater than a negative number, I can tell right away that my interval notation is going to be negative infinity plus infinity. Okay? And I can do exactly the same thing for example number 12. An absolute value, because it's always greater than a negative number, that means right here it's a no solution. Okay? And you have to be able to answer this question very quickly. All right? Now, please, again, practice problem. If you are going to work with me in class some new problem from your book, please come with your note filled up with all the problem that I didn't do in this video. You should have done this video by yourself, and see you in class. Thank you.